Good day, ladies and gentlemen. How are you doing today? Welcome back to Economics YouTube channel. In fact, thank you for joining us. It's been a while. I recorded a video like this. Others have been using PowerPoint and whatever. It's good to be here. It's good to be here. So, probability theory. We had to cover this because the student that we're taking care of primarily, English economics students, they these topics just got introduced into their course outline, so we just have deal with it as well. Alright, so what's probability theory about? Now, probability is actually talking about chance. Okay, so probability theory is a theory that aims to give a logical mathematical explanation to events or occurrences, or let me say to events that happen by chance. Do you understand? So it's trying to probability theory is a theory that is trying to give it's a theory that gives, you understand, or let me put it attempts to give logical explanation to events that have a chance of happening. Do you understand? Have a chance of happening. All right, so let's just look at what is officially on the board. So probability theory is the science, right? The science of uncertainty. So it's a mathematical framework that allows for the analysis of chance events in a logical manner. It's a science, it's a mathematical analysis, logical framework, chance events in a logical manner. Alright, so we have examples. For example, if a die is rolled once, what is the probability of obtaining number one, a 4? When you roll the dice, some of us that played Ludo or probably still do, right? You make sure of 2 dice, right? So if one of them is rolled, what's the probability that you're going to get a 4? So sometimes the question might be rolled, the question might be tossed. If you toss a die or whatever. So what is the chance of getting a 4? What's the chance of getting an odd number? What's the chance of getting a 4 and a 6? Like 4 and a 6. Okay, and then what's the chance of getting an even or an odd number? Okay, now if you look at a die, so how many numbers can you get from a die? Okay, basically speaking, you can get 1, there's 1 on it, 1 dot, 2, 3, 4, 5, 6. So all of those numbers I can get, they are what we call the sample space. Let me just write the sample space. So the sample space equals, for a die that is tossed once, equals 1, there's 2, there's 3, there's 4, there's 5, there's 6. So there are 6 possible events that can occur, right, if you toss a die. Now, if you're looking at the probability of obtaining a 4, okay, so how to do it is, how many times you have 4 here? Once, right? So we say the frequency, right? So the normal formula for probabilities, the frequency of the events that you're interested in divided by the total number of occurrences. Let me say frequency divided by the sample space. Do you understand? So here we have, how many times do you have 4 here? 1, right? So 4 has a frequency of happening 1 time, 1, then divided by how many possible events do you have when you toss a die? 6. So the probability of obtaining a 4 is 1 over 6 if you toss a die once. That's it. And the same thing goes for probability of obtaining a 1. A 1 occurs only 1 time, so 1 divided by the sample space, by the sum of the different number of occurrences that you're going to have. The same thing for 4, 5, for each and every one of them. So what is the probability of obtaining a 7? For real? Is there 7 in your sample space? No. So let me just call this probability of obtaining a 4 equals f of n equals 1 over 6. Right? Now the probability of obtaining a 7 is 0. 0 over 6, which is 0. Because the 7 is not here. Do you understand? 7 is not there. So that's how it works. So how do you get a 7 when you only have 1, 2, 3, 4, 5, 6? Do you get it? Alright, now the next one is probability of getting an odd number. I think I should say at this point that you are going to be having assignments. That's how we're doing our videos for a while now. So you'll be having standard assignments at the end of every class. You just have to just brace yourself up for that. Now, what's the probability of obtaining an odd number? Interesting, right? Okay, so an odd number, which is number 2. How many odd numbers you have in the sample space? You have odd numbers are numbers that can be divided by 2 and then there'll be a remainder, right? To remain 1. So, okay, fine. Is that really the definition of an odd number? Anyways, so we have odd numbers. We have 1, we have 3, and then we have 5. So we have 3 odd numbers. Do you understand? So the probability of obtaining an odd number, so P of an odd number, okay, is you are looking at how many odd numbers you have. You have 1, you have 3, you have 5, right? So what's your sample space? 1, 2, 3, 4, 5, 6. So if you look at it, you have 1, 2, 3 odd numbers divided by the sample space 6. So the probability of obtaining an odd number is just 1/2. And if you look at it, that's true because on a die, you have half of the numbers on a die are odd numbers, right? Then half of the other half are even numbers, right? So that's cool. Now another way to do this, right, is you can just say we have the probability that we are going to have a number that's on the die. Like for example, the way we got probability of 4 is 1/6. So for the odd numbers, you can just say probability of 3. No, 1 is the first odd number, right? So that gives you 1/6. That's the chance that you are going to find number 1. Then the chance that you find what are you calling now? Number 5. 5 occurs just once. So that's still 1/6 plus 3. 3 occurs once too. Then plus probability that you're going to get a 5. That's also 1/6. So by the time they have the same denominator. So 1 plus 1 plus 1, that's 3/6, and then you still have your half. Simple, basic. Hope you're getting it. Hope you enjoy yourself. Okay, maybe you want to take a little pause. Now, what's the probability of obtaining a 4 and a 6? Well, this one calls for like some form of deep thinking. Like a 4 and a 6. How? You are tossing a single die. You understand? You're tossing a single die. How am I going to get a 4 and a 6? Like I'm going to get one number, just one number. You can't get 2 numbers. You understand? So the probability of you having a 4 and a 6 on a die is practically impossible. It's 0. Do you get it? So one thing that I should say at this point, because I may not be able to say it in the other, we should be having like I don't know, maybe like about 4 to 5 classes. Do you understand, on probability as of this particular time? So one thing that I should let you know is that you're going to learn the basic principles of probability from this class or from this series. Do you understand? But then quite a huge chunk of probability theory is about common sense. So like you know the principles, then it's about how you apply the principles. You get it? So begin to think. For example, here, thankfully you know what a die is. So what are you calculating for real? If you toss a die once, you can't get a 7. You can't get a 7. That's what I did the first time I got. What is it? Probability of getting a 7 is 0. And then if you toss a die once, you can't get 2 numbers. So it's either you get 1, it's either you get 2, because you are tossing the die just once. Okay, so the probability of you getting a 4 and a 6. So we call that, we do like this, probability of 4 and okay, number 3, probability of getting a 4 and 6 is 0. You can't do it because you're tossing the die once. Okay. If we're tossing 2 dice, for example, that makes sense. You know, when you're playing Ludo, 6-4, 6-3, 6-1, all of those, so you can get a 4 and a 6. You get it, but on one die, no. Now, what's the probability of getting an even number or an odd number? This is interesting. An even number, an even or odd number. The probability of getting an even or odd number. So how do we go about that? Now, look at it again. You have your entire sample space is 1, 2, 3, 4, 5, 6, right? So you want to look at the probability of getting an. Okay, what are the odd numbers? Okay, what are the odd numbers? So the odd numbers, are, let me just say odd numbers. You have 1, 3, and 5, right? Then even numbers, We have 2, 4, 6. So the probability of getting an odd or an even number. That is, you may have an odd number, right? You may have an even number as well. So the probability of getting either, right, would be what? So you can get a 1, right? You can get a 2, you can get a 3, you can get a 4, you can get a 5, and you can get a 6. That's the point. When you're getting, when you toss it once, you can get one odd number, you can get. Do you understand? So you can get any of the two, and because we know that the numbers on the die, they are either odd numbers or even numbers between number 1 to 6. So definitely we can get any of the numbers. That's what you're trying to say. So that means if I roll the die like this, so the number that may come up may be 1. Do you understand? If I roll the die like this, the number that may come up maybe 6. Do you understand it? So like I can literally get, whenever I toss a die, it is either an odd number that shows up or an even number that shows up. Do you understand? So the probability of getting either an odd number or an even number is certain, is sure. Whenever I toss the die like this, I'm going to get a number. A number is going to be between 1 and 6, right? It's going to be an odd or an even number. So that's why the chance is 100%. Whenever I toss it, it's going to be 100%. So when you look at this, probability of an odd number or an even number, I get all of this, and divided by the sample space. And the sample space is still 1 to 6. Do you understand? So we have 6 over 6, and then that is 1. Alright, so that's it. It is certain that whenever you toss a die, you will get either an odd number or an even number. So let me just quickly talk about the range of probability values. So you can get 0, right, or 0%. So that means this event have no chance of happening. This particular event, for example, when I toss a die, can I get a 7? You can't get a 7, right? No chance of happening. Then probability value could be 1 or 100%. I can say 1, or I multiply my 1 by 100, converting it to percentage, so I have 100%. That's telling me that this particular event will definitely happen. It is surely gonna happen. Okay, an example of that, I toss a die. Would I get an odd or an even number? It is sure. I'm going to get either of the two. Do you understand? So 100%. My probability for that is 1. Are you getting it? Now, probability can now be between 0 and 1 as well. Let's say probability of I think we did this guy. Probability of getting a 4, 1 over 6. And then if you divide 1 over, if you do it 1 over 6, you get like 0.16 or something. Maybe, I don't know, I'm not really calculating it, but I think it's like 0.167, something like that. I hope it is right. I think it is. Okay, so this is telling us that, okay, there is a 0.167 chance of getting a 4 whenever a die is tossed once, or there is a same as there is a 16.7% chance of getting a 4 when I toss a die once. You understand it? Now let's move on to other things. So like I said earlier, the range of probability values, the probability value could be 0, could be 1, there could be a figure between 0, 1 and 1. That lets you know that a probability value cannot be more than 1. That is, the chance that an event is going to happen cannot be more than 100%. So at best, it's 100%, which means it is certain that's going to happen. Or if it is like I don't know, the worst thing that can happen is that the event is not going to happen at all, which give you 0%. So like your probability value can never give you a number. Probability of an event happening will not give you a number more than 1 or lesser than 0. That is, you are never going to be getting a negative number, and you won't be getting a number more than 1. Right? So like have that at the back of your mind as one of the basic principles of probability. So I was looking at so I think I've settled that. So the next one is complementing probability. If you remember complementing Venn diagrams, let's say you have this circle, which is representing maybe A, right? So this circle is all about what is in A. Now you see the remaining space, right, inside this square is the A complement. It could be written as AC or A prime. It's basically just telling you the elements in the universal set that is not contained in A. The elements universal set that is not contained in set A. Now, literally, what that means in probability, right? When we're looking at complementing probability, is that it measures the probability. It's the probability that tells us that an event is not going to happen. Do you understand? So it is the probability that an event will not happen. Now, for example, remember the die that we're looking at the first time. So what is the probability of not obtaining a 4? Do you understand? If you recall, let me say recall that P of A was 1 over no, let me just say P of 4. Just say that 4. P of obtaining a 4 was 1 over 6. How did we get that? We said okay, only event 4 will happen out of events 1, 2, 3, 4, 5, 6. Okay. Frequency of event 4 is just 1. Then all of this is some of the frequencies you have 6. Right? Okay, so the probability that 4 is not going to show up, right, is you remove 4 from the sample space. So we are left with probability of 4, say prime, or probability of 4 complements. It's the same thing. So if you look at it, we'll be having 1, 2, 3, 4, 5, 6 divided by the sample space 1, 2, 3, 4, 5, and 6. So everything that are doing probability will be divided by the total sample space, except we are dealing with conditional probability, where in that case you will also be dealing with a particular kind of sample space. So it's just that there is like a new yardstick. But when we get there, we'll talk about it. So now if you look at this, how many events do you have here? 1, 2, 3, 4, 5. 5 over 6. So probability of event 4 not happening is simply 5 over 6. Now mathematically or formally, how do you do that? Now if the probability of 4 equals 1 over 6, then definitely probability of 4 complements is simply 1, right, minus 1 over 6. That's the principle. So by the time you do that, for LCM, 6, 1 is 6, 6 multiplied by 1, 6 minus 6 and 6, 1, so you have 5 over 6. So the probability of an event not happening is 1 minus the probability of the event happening. Basic, right? Now the next thing, I think that should be the last one we're talking about today, or in this particular video, we're looking at the probability of not obtaining a 3 or 5. Okay, not obtaining a 3 or 5. Now if we look for the probability, let me call that in II. So if we're looking for the probability of 3 or 5, so definitely we are saying we have either 3 or 5 out of the entire sample space. 1, 2, 3, 4, 5, and 6. In essence, probability of 3 or 5 is 2 over 6. Do you get it? So now if you want to use this formula, okay, that's P over 3 or 5. Let me do like complement like this, take care of the whole thing. That will be 1 minus 2 over 6. By the time you do that, you're getting a 4 over 6. Right? But if you want to like prove this thing and do it manually, okay, fine. Probability of 3 or 5 not happening, okay, not happening equals, you need to look at the sample space. You have other things except 3 or 5. So we have 1, 2, 4, 6 divided by 1 to 6. Okay, let me just put like that. I want to write something like this in example. Alright, and in fact, I don't know if you really need this final stuff. Okay, is what you need to find out. That's the answer. Just know how to do what you're supposed to do. So we have 4 events here divided by 6. Yeah, so that's it. I hope you enjoyed the class. So the next thing we are going to now is an assignment. Like an assignment. So we're going into by the 2 and then we are going to enjoy probability. Alright, we got this assignment. If a die is tossed once, okay, anyway, it's a die, right? Okay, let me put it anyway. If a die is tossed once, okay, what is the probability of obtaining 1, a 0, a 6, a 3, 4, or 5? IV, a number strictly lower than 6. Okay, Then a prime number. Okay, so just look at the sample space, which of them is a prime number, identify it, and then do what you're supposed to do. Okay, when a coin is tossed, now this is the second part. When a coin is tossed once, what is the probability of obtaining a tail, a head, or tail? Now, for a coin just has two sides. Side one, a coin just two sides. So like you just one of the side is the head, the other side is the tail. So we just label it A and B. Do you understand? So the sample space there is going to be two because you can only have head or tail. So like, do you understand what I'm trying to say now? So it's a sample space of two. Then what's the probability of getting a tail, a head, or a tail? So that's it. Very simple stuff. So in our next class, we're looking at a probability with or without replacement. I think maybe a couple other things. Thank you. See you there. Bye.